our calculator, and if you're set up in that um, I'm sorry, the table, if your table's set up as that ask, don't worry about that. We are going to adjust our window a little bit, so I'll help you with adjusting your window as well. So looking at number 7, we've got use a graphing calculator to solve each equation in the interval from 0 to 2 pi. That theta, 0 to 2 pi, that's what I want my x window to be set up as. It's already set up like that. If you did the problem number 5, you should be set to go on that one. Round your answers to the nearest hundredth. We'll do that when we get our answers. Now, as far as the y-axis. So in our window, we put our y's as negative 200 to 200. Our first problem is tangent theta equals 2. Let's clear that out. Tangent theta, which is our x, is going to equal 2. So like we did with cosine, we're going to have our tangent in one of our y's, and then 2 is going to be in our other y. Now I need to see where it's going to intersect at 2. And thinking about my window, I want to at least see 2, so I'm going to probably want to go up to 3, negative 3, so I can see where that line of 2 is. Remember, tangent's going to go all the way up to positive infinity, negative infinity. It's going to ride that asymptote, so it's going to keep going on forever. But I just need to see up to 2. So I'm going to go to my window. Let's just make it negative 3 to positive 3, and then we'll just count by ones. So you can pause right here if you want to see this window. We've got a 2 pi with a pi scale, and then negative 3 to 3 with a 1 scale. And you hit graph, and you should start to see your tangent curves, and then also where tangent is equal to 2, which is going to be those intersections. The only way to find those intersections is to head to second calc, number 5. And as long as my blip is on this one, we're just going to go as close as we can to where that intersection is. Hit enter, enter, enter. And we're going to round to the nearest hundredth, so that's going to be about 4.25. I'm looking at what is my x, my theta at that position, 4.25. We'll do our second one. Hit second calc, go down to number 5. And your blip now is right here. To get to this curve over here, you have to go all the way down. Then it's going to jump the asymptote and come down the next curve. So there it is. So you got to go down that asymptote. It's going to eventually jump over the asymptote and then get your blip as close as you can. So what I did there is I just hit the left arrow until I jumped over, and now I'm right there. Then you're going to again hit enter, enter, enter. And rounding to the nearest hundredth, this would be 1.11. So again, your two answers were 4.25 for the first one, or actually the second one, we found it first, and then 1.11. There's your two tangent measures. Now, one thing unique about 4.25 and 1.11, if you subtracted those two, you get 4.25 minus 1.11. What special number is that 3.14, if you think about that? That's pi. So that's that period length. So this graph has a period of pi because it's got a b-value of 1. Pi over 1 is just pi. So that's going to give us that period length of 1. But those two solutions are also pi units apart. So that's pi units apart to get to those two solutions. Heading into problem 2. 6 tangent to theta. Now we're getting an amplitude of 6, and we want to see when it's equal to 1. 6 tangent to theta, use your x, and we want to find out when is that equal to 1. Now my window is still going to be okay because I'm going to be able to see 1, and then I'm going to see where that intersects my tangent. The 6 just tells you where that point is that's halfway between your first point and that first asymptote. So the 6, yeah, that's like the amplitude like we did with sine and cosine, but tangent goes to infinity, negative infinity. We're never going to be able to make a y window big enough. So we can keep our same y window. And there's the window again if you want to pause right here and record that window, 2 pi, pi, negative 3 to 3, 1 scale. Now we head to our graph. There's our tangent curves, and we've got 1, 2, 3, 4 of those solutions. So we're going to go second calc, intersect, get as close as you can to that first curve, enter, enter, enter. There's your answer, 3.22. Now, if you wanted to get fancy, you could just add a period to find this next solution. And the period would have been pi over 2, so you could add pi over 2, which is about 1.57 if you wanted to get really fancy. But we'll just calculate it again using an intersection. Second calc, number 5. Remember to jump that asymptote. Just keep going to the right. It'll get there eventually. And enter, enter, enter. And that's about 4.79. And if you do 3.22 to 4.79, that is about 1.57. So I just added on another period to get to that next solution. And let's head into the last one. Actually, there's 2 more. We got to go back, so I'm going to hit left. It's going to take a little while. It's got to go all the way across that asymptote. Across the next one. And here we come. And there it is, 1, 2, 3, about 1.65. Which is 1.57 less than 3.22. And then we'll head to our last one, which is number 5. And right there it is. Enter, enter, enter. About 0.08. Again, just subtract another 1.57 from that last answer we got, 1.65. That'll be your next. So just recall that each cycle, each distance between these curves is a period, so pi over 2. So that concludes our 13.6 with the tangent.